Hello, once again, AP students. Our last of the Unit 1 videos then today. This is the intermediate value theorem. I believe it's topic 116 in Unit 1. And this is the first of our existence theorems of 3. And again, one of the 3 most important topics of Unit 1. I suppose limits, continuity, and then the IVT, and you'll hear me refer to this as just the IVT, recognizing we're talking about the intermediate value theorem. So let's talk about the word intermediate for just a moment. An intermediate school is between elementary and middle schools. If you were up in Hamilton County, Southeastern School District, you'd probably be familiar with intermediate schools. Again, the idea of that intermediate school, it's in between the elementary and middle schools. And so this theorem, also the word association I'd like you to think of for intermediate would be in between. So if you have a number that's between 2 given function values of a function that's continuous, then there has to be a value C, as we call it typically, that's in between the generating function values A and B, such that f of C is equal to that value K that's between the 2 original. That sounds pretty, I suppose, complicated, but let's see if we can break it down a little bit. First and foremost, the function has to be continuous for this to apply. And in the actual guided notes, you'll see a situation where the function is not continuous, and therefore the function is not guaranteed to have that value. It possibly could, but not guaranteed to. The IVT guarantees that such existence is going to be the case. So typically on the AP test, you'd be asked to show or prove or find the number that is that value C that's between again, A and B, such that its function values is between f of A and f of B. So the given information, again, the hypothesis of this conditional, the function is continuous, and K is some number between f of A and f of B. So you see in the diagram in the bottom left, and my first 2 steps there, I've just mentioned those, f of x continuous and K between f of A and f of B. There has to be then a C, and it's guaranteed by the intermediate value theorem, by the IVT. There at least exists at least 1 C. In our diagram, there happen to be 3 different values of C that is between those. But since, again, K is between those 2, and just a second, this is my iPad turned off already, so let's see if I can't get that diagram back up. That since indeed K is between f of A and f of B, that situation has been met. The function is continuous. K is between these 2 values, f of A and f of B. There has to be some C between A and B, and it could be in the closed interval, you notice. It's continuous in the closed interval. There has to be a number C in A and B. So it could be at A or it could be at B, such that f of C is equal to K. You'll notice K is any number between f of A and f of B. So K is not typically f of A or f of B. When we talk about between, we're not necessarily denoting inclusivity. But again, the scenario is there has to be some C, in this case, 3 such cases where f of C is equal to K. And that's the intermediate value theorem. 1 of 3 will also have the extreme value theorem, and then in addition later, the mean value theorem. But this is a question you can be assured of that will be on the AP test in some fashion, either multiple choice or free response, at least part of that question perhaps. But the existence of a number that's between 2 numbers, and again, word association will be intermediate, pair that with in between. And hopefully that word association will help you again remember. And like all of our existence theorems, the function has to be continuous for this to be true. All right, so at this point, we're done with Unit 1. We'll try to tie up any loose ends when we're back at school. And hope you have a last couple of restful days, and we'll see you soon. Bye now.